Okay, for this worksheet, we are matching units again. So for force, it's still going to be newtons. For work or energy, we are dealing with joules. For mechanical advantage, there are no units. For momentum, we would have kilogram meters per second. For distance, we have 25 meters. And for power, that is one that we do in watts. Okay, next is our matching. Uses energy and can create energy. Okay, well, again, we don't really create energy per se, but we transfer it. Okay, so in that case, that one's going to be work. Okay, then the units for energy and work are going to be joules. The rate of doing work, that's going to be power, and then has the ability to create forces and stored work. That would be energy. Okay, then next, we're saying if it's more or less or the same amount of work. Okay, you use more force to move an object. Okay, so that's saying that it's just more force, nothing else is changing, so that one would be more. You lift a 20 Newton object faster. Okay, so that one's going to be the same. You're just doing it more quickly. The rate you're doing it is faster. You raise an object a shorter height. That's going to be less because it's force times distance. Okay, if you move a lighter object, all right, that one's going to be less because you used less force to move it. Okay, and then you move an object further, that one's or farther, that's going to be more because the distance is greater. Okay. So next we're going to say yes or no if this person is doing work. Okay. When pushing a 1,000 Newton car 20 meters, yes, there's force and distance. Lifting a rock off the ground, yes, there's force and distance. Holding a book in their hands, no, that's not moving a distance. Pushing hard against a brick wall, no, no distance. And when walking up the stairs, yes, you're moving yourself up the stairs a distance. Okay, the next one, more or less power. Remember, power is work over time, so it's the rate at which you do work. An engine can lift an object faster, that's more power. Someone takes more time to push a car, that's less power. You take the same amount of time to do more work. Okay, in that case, you're going to have greater power because the work is greater on top. Same distance, same time, more force. That one would be the same. Or no, I'm sorry, that one would be if we do same distance and same time, but we use more force, that means work is going to be greater, so it's going to be more power. Maybe you're using a heavier object. Oops, more. Okay. Next, you do 45 joules of work in 3 seconds. How much power do you use? Our knowns are going to be work is 45 joules, time is 3 seconds. Unknown is power. Our equation, power equals work over time, and our solution is going to be power equals 45 joules over 3 seconds, which gives us 15 watts. Okay? Next one down. A car uses 2,500 joules in 25 seconds. Find power. Okay, so this is kind of the same. Our work, 2,500 joules. Time is 25 seconds. Our unknown is power. Equation, power equals work over time. Substitute and solve, we get power equals 2,500 joules over 25 seconds, which is going to give us 100 watts. You move a 25 Newton object up, or 25 Newton object 5 meters. How much work did you do? Okay, so this one's a work one again. We've got force equals 25 newtons, distance equals 5 meters. Our unknown is work. Our equation, work equals force times distance. Our solution, work equals 25 newtons times 5 meters, which gives us 125 joules of work. Okay, next, a 60-watt light bulb runs for 5 seconds. How much energy does it use? Okay, so we know that our power is 60 watts. We know our time is 5 seconds. Our unknown is how much energy does it use, or basically work. Okay, our equation, power equals work over time. We want to multiply by time on both sides to get work by itself. That's going to give us power times time equals work. We're going to substitute in. We're going to get 60 watts times 5 seconds. That's going to give us 300 joules. Oops, W there. Okay. All right, next one. You carry a 20 Newton bag of dog food up a 6-meter flight of stairs. How much work was done? Okay, so we're carrying the 20 Newton bag of dog food up a 6-meter flight of stairs. So our known is going to be force equals 20 newtons, our distance 6 meters, and our unknown is work. So our equation is just going to be work equals force times distance. Our solution is going to be work equals 20 newtons times 6 meters, which is going to give us 120 joules. Okay, so next, you push a 10 Newton object 10 meters, how much work was done? So, same thing, force, 10 newtons, distance, 10 meters, unknown work, equation, work equals force times distance, substitute and solve, work equals 10 newtons times 10 meters equals 100 joules. Okay, so you push down on a 3 Newton box for 10 minutes, how much work was done? Okay, we're going to do, this one's going to be in the solutions because that's the exact same thing that we just did. On the same object as in the previous question, you have to push with 15 Newton. Okay, so it builds. So we're going to do this one. All right, force, 3 newtons, time equals 10 minutes. Okay, how much work was done? Oh, so this one should be pretty easy because our equation for work is force times distance. Okay, so you push down on the box for 10 minutes, doesn't tell you you moved it at all. So the solution is going to be 0 joules. Okay, on the same object as in the previous question, you have to push with 15 newtons of force to move it 10 meters. So I guess this is referring to this one. Okay, to move it 10 meters, how much work do you do? Okay, so it's the same as the previous one. Okay, so we're just going to point up to there for K. Well, we got to change the force. So force equals 15 newtons, distance equals 10 meters. Our unknown is work again. Our equation is again work equals force times distance. Our solution is going to be work equals 15 newtons times 10 meters, which is going to be 150 joules. Okay, next one. We want to figure out the distance this time. So we do 35 joules of work. We move it to move a 7 Newton object. So the force is 7 newtons. And our unknown is distance. Our equation, work equals force times distance. We want to solve for distance, so we divide by force. And we're going to get distance equals work over force. Substitute and solve, we're going to get distance equals 35 joules divided by 7 newtons. That's going to give us 5 meters. Okay, for the last question it asks, what was the difference in the work to move the object and the work you do on the previous two? Okay, and then it says, why was there a difference? Okay, so the difference was that we did 150 joules of work here versus 100 in the previous one. So we did more work, okay? The reason there might be a difference, well, the distance was the same and the object was the same, so it might be something like it would probably be greater resistance, or perhaps even though it says the same object, maybe it's more massive for whatever reason in the second case. But there's going to be more resistance is the more likely reason. Okay? More work.